ThousandEyes. I'm the ThousandEyes specialist that aligns with Philly Select. And for today, like Brian mentioned, we're going to take a look at a few demonstrations of use cases that come up often. So we've got 3 different demos that we'll walk through. But before we hop into a demonstration, really briefly, we'll just talk through exactly what ThousandEyes is, who we are, what we do. No slides today, so we'll use the platform here to provide a visual aid. But if we talk about ThousandEyes from an extremely high level, what we're doing is relatively simple. We generate synthetic traffic from a software-based agent, and we can target various things, whether it's a URL, another one of our agents, an IP address. What I'm really getting at is you have quite a bit of flexibility in regard to what you can test and the use cases that are available when using ThousandEyes. But for today, we'll look at 3 different use cases, the first being what we call customer digital experience. So when we talk about ThousandEyes and the way that we support most customers, it'll be from one of 3 different buckets of use cases. As I mentioned, the first being customer digital experience. And for each of these, really just think about it as whose perspective are we gaining this data from? So if we're talking about the customer, we're going to be leveraging a series of vantage points that ThousandEyes will manage and maintain. We call them cloud agents. Those cloud agents are going to be spread across the globe. We have nearly 500 of them today. And to configure a test using them, your customer simply just has to select from a dropdown what agents they would like to deploy this synthetic traffic from. So, as I mentioned, we need a target. If you notice here on the left-hand side, mid-page, we are targeting, in this case, support.activision. So Activision gaming company, think Call of Duty is a very popular one of their games. When players have a poor experience, they're going to reach out to support. And in this case, we're monitoring that support portal for Activision. And that portal actually lives in Salesforce. It's one of those Salesforce community cloud type of pages. So again, our target, support.activision. And then where are we deploying this test from? So if we take a look here, we've got a table view, which is showing us across the globe, the cloud agents that we're collecting this data from. But we'll switch back over to our map here. Few additional things to call out just with the UI itself. You'll notice this green timeline. This green timeline is an average of all agents. So if we see a deviation from 100% availability, because that's the metric we're looking at, we'd want to identify, okay, where is this dip in availability? But before we hop into that, you'll notice on the left-hand side here, we've got different layers. So this test is one of our web-specific tests, right? We're looking at the application layer, and we're starting at the very top here with page load. So page load, that's going to provide you with information on, well, we'll render the full page. So we'll take a look at all objects on that page and show you in waterfall view, what does the total time look like? And we'll break that out by provider. We'll take a look at that in just a moment. However, as we drill down through these metrics on the left, that's where we begin to build out our story. So at first glance, within page load, the metrics provided there is just page load time. We can apply a filter if we wanted to look at a specific agent in particular, but if I look at this bottom timeline, I'm not seeing anything abnormal, right? Page load time looks pretty static. This top line is going to be basically wherever I'm zoomed in the bottom here. So this is actually something called a share link. A share link is a perpetual read-only link that you can generate from the platform to collaborate either internally or, you could send this to Salesforce themselves, right, to help with just assisting in triage. But again, nothing major. I don't notice anything aside from these red bars that's out of place here. So we would drill down to our next layer. Here within HTTP server, we can see availability, response time, and throughput. With availability, now we see that drop. We can see there's a dip in that 100% availability. We'll click here. And now if we scroll down a bit on the map, we can see, okay, who is affected? If I hover over any of these, we can see what the error was and ultimately what agent threw that error up. So in Germany, SSL, Connect in Spain, Connect, SSL. So right now we have some general information, right? Because we're not just doing a standard ping, we're connecting and we're showing you the connection status by phase. So we can start to understand, hey, is this app or is it network, just by looking at these phases here. DNS, if we saw an error there, I mean, that's pretty straightforward. We can imagine, hey, this issue is associated with a DNS server not being identifiable. But as we work down the stack here, connect, that's simply saying, hey, can device A connect and speak with device B across whatever network path we're talking about? So if we see an issue with connect, we can start to say, hey, this looks like it's more than likely network. SSL is going to be associated with that three-way handshake where we're able to establish our SSL connect. And then as we work our way down here with send and receive, if we were seeing errors here, that would lead us to believe, hey, maybe this is on the app side of the house. Is that server not able to provide a response? And is that related to not the network, but the actual performance of that server? All right, so now we know who's affected. We know there's a dip in availability. I can get a more granular view by looking at a table. And then what I would want to do is move around within this event. If I click one round to the right, what do things look like? Okay, we could see that South Africa is still there. How about one more? Now it's all four again. But really the main idea here, again, is to understand who's affected and why. So we still don't have that full story. But again, we're starting to build one out. We now understand, hey, this is probably network related. So we can then go down to the network layer and take a look at performance as it regards to the standard network stuff, packet loss, latency, jitter, and even BGP routing. But here we can see we've got loss as our metric that we're highlighting. We can see that there are increases in loss. Again, this is that average being pulled up. And being pulled up to 19.2% when we have this many agents across the board means that this is a significant type of event. You know, we would previously have configured customizable alerts. We'd know that if we saw packet loss like this, we would want to receive some sort of automated notification. And ThousandEyes is able to natively integrate with ITSM tools like ServiceNow. We also natively integrate with Slack, PagerDuty, and AppDynamics, as many of you know. But the main takeaway here is being proactive. That's really what we're going for. That's why ThousandEyes is valued by its customers. So in this case, you know, maybe we don't have ServiceNow. ThousandEyes has a RESTful API. We can integrate with another ticketing service, so long as, you know, API data ingestion or webhook was a viable option. But back to this here. So we see the packet loss. We know where it is. We can take a look at our table and we can see that it is substantial for those impacted. But now we want to understand, okay, who's to blame? What is the root cause of this specific event? So we'd scroll back up and go to our path visualization. So now here, this is where we're going to be able to see versus the average, who's having a bad time. And as I scroll down, we can see that there are multiple nodes, right? So Salesforce is using content delivery network technology to diversify just geographically who's hitting what. And we can see that all of the folks, all of the regions that are having a bad time are going to be hitting on the right-hand side here, this instance in England. Scroll back up a bit, or down, sorry. We do see some additional packet loss here. And it is, oh, no, that's not odd. I was gonna say, why are they coming into San Francisco? But it does make sense here. But let's highlight a couple. Let's clean this up so we're not looking at quite so many data points. All right. So now we could say, just show me those four. And now we'll talk about the path a bit. So I've applied a filter below. You can do the same thing above here. Let's just pick Johannesburg, because I haven't called this out yet. Okay. When I apply a filter up top to the timeline, you'll notice now we've got a solid red line. That's going to be the filter. That's Johannesburg. The lighter red, orangish solid bar, that's going to be the average. So this is a great way to identify, okay, how much worse was the experience had in South Africa versus everywhere else. But back down to the filter we've applied on the path. Let's talk about just in general what we're looking at here. So if I hover over that South African agent, we can see some great information, IP address of that source, right? So again, this is a cloud agent. ThousandEyes manages and maintains this point of presence in South Africa. But then as we hover over the next node, now we can see, okay, what are the transit hops? What providers are actually serving this path as we connect from South Africa to Salesforce, again, in London. So we can see the provider. We'll be able to see any handoff from that provider as we work our way across here. Same provider. There's our switch. So now we're in Johannesburg. We see that red, that link between Johannesburg and London, right? So this is transatlantic passage of our data. So ultimately, if there is any sort of link delay, any packet loss, we're going to highlight that on the path here. You'll also notice that we've got some different colors of hops. Light blue, transit, right? This is going to be the open internet. As we start to see these teal nodes, we're now entering the Salesforce network. And you see we can go relatively deep. We can identify multiple hops within Salesforce. And this red one here is showing us that a specific node within Salesforce is dropping packets. And this would be a bit of a smoking gun scenario. This would be data that could be shared directly with Salesforce, and it would be difficult to challenge that this issue is taking place within their network and for quite some time. If I wanted to just 100% ensure that I'm looking at the same data, the same node, you can highlight that as well. Say, only show me agents that use this node. And now we see we dropped one on the left here. All three of these locations will be hitting that node potentially as they come into Salesforce's network. Very good. So the final thing we'll show, and this isn't really applicable to the event, however, BGP pathing can also be represented using ThousandEyes. So let's take a look at steady state. We'll look right here. And we'll explain exactly what we are looking at. So again, Salesforce, this is one of the community cloud pages being leveraged by Activision. As I hover here, we can see our prefix, the associated AS. And then what we do at ThousandEyes is we build out backwards towards the left-hand side here, all of these global collectors. So we partner with the Route Project as well as Right to Use. These are going to be nonprofit, many of them are university funded collectors internationally that are mapping out the internet, all of the routing tables. So the information we receive from these collectors will show us all of these peering relationships, again, as we work backwards from Salesforce. If there's a change, we'll call that out in a very similar way visually to an issue with loss or latency. So this here is showing us that there was a path change that took place. This is quite some time ago, a couple of years ago in June. So now what changes below here? Quite a bit in this example. The main call out is going to be that a dark red line, that's going to be a route that was introduced. A dotted red line, those are routes that were removed. So there was an extremely large shuffle that took place to try to restore service here. Click over one more, we can now see steady state and the changes holding as that recent change took place in the previous round. Okay, so just one final thing to tie off on here. This is a perfect example almost of a network issue that is associated with the target network. We see it below here. We can see where the packet loss exists. Again, bit of a smoking gun. This would be the type of event that we would want to send this share link directly to Salesforce. Good news there is Salesforce, they speak fluent ThousandEyes and they would have no problem deciphering this data. But just in general, the share links are a great way for organizations just to collaborate internally. All right, so that was our outside in. That was our customer digital experience use case. If we were to kind of flip that test strategy on its head, We would then be testing from within your network out to things like SaaS or public cloud workloads, supporting and providing you visibility from the perspective of your employee. So real quick, we do that in two ways. We can either have enterprise agents, the agent that's software-based again, a VM, a Linux package that would live within your network in brick and mortar locations. We can either test from those to things like, again, Salesforce, Workday, any SaaS, any public cloud workload, even applications that are still hosted by your customer on-prem. We can test to those. We can also use a different agent called an endpoint agent, which is deployed on a laptop or desktop. That endpoint agent's going to be applicable to devices that are running Windows or Mac operating system. So today we do not have mobile capabilities, but the general idea behind that endpoint agent is to, again, just quickly and easily visually identify, is this an application issue? Is this a network issue? Or in the case of the endpoint, does this have to do with the local network? Is the issue due to maybe poor Wi-Fi signal strength? Is the individual who's having an issue connected to maybe a mobile hotspot? And the problem is just that they're using their cell phone for internet connectivity. But okay, we've set the stage here. This is the data you've received from that endpoint agent. What we're looking at is our browser views. That agent, it collects data in two ways. One is through just whitelisting URLs you would like ThousandEyes to come along for the ride on when your customers' employees navigate to those pages. That's an extremely active, real-time type of monitoring that's taking place. And then second, you can also set up a scheduled test. That scheduled test would be more of a perpetual test, a static type test. In that case, you'd be identifying, hey, we want to target Salesforce, and we want that test to always occur so long as the device is powered on and connected to a network. Both are powerful. Both have their strengths in different areas. But what we're looking at here is the browser session test. The browser session test is going to provide you insight into the web layer, that application layer, as well as the network. The biggest difference, I think, when you first look at this page is just visually the UI is much different. And we see this giant 87%. That's our experience score. So just really quick, the experience score is going to be a ThousandEyes proprietary metric, if you will. It's looking at availability, the total time to load the page, and errors. If there's any negative across those metrics, it's going to drop your experience score. Very good. Okay, so now we'll look at a specific issue that someone had. If I were to hover here, a few additional call outs, you'll notice that we've got the date and time. So when did this actual round of testing take place? You can also see that /557 there in gray. What we're seeing with that gray line that seems to undulate quite a bit is how many people were connected and actively conducting tests during this round. So this is actually a snapshot, an example of the ThousandEyes employee deployment. And in the case we're about to look at, we had Hans, one of our employees, who was having a tough time when trying to connect to workday.com. So, ton of data, 550 something folks that we're looking at here. We'll need to apply some filters. So if I want to add a filter, say, okay, I just want to see a specific agent, in this case, Hans. And I only want to see issues when they're connecting to, oh, click the wrong one. Issues when they are connecting to Workday. Now we can see as we make those changes, our timeline is going to shift. Now we can see there are 11 people that are actively conducting this test at this time. But right now everything looks green. If I were to look at the bottom here, the experience score that Hans is achieving is 91%. No issues there. Obviously we wouldn't flag this. But as I click through, just taking a look, when did this issue take place? We can now see some things change. The experience to Workday is now average versus good. I'm going to click through a few more and just see if that trend maintains. And we can see that it does. So we'll go back. We've got this red here. We do have an error. Let's click into Workday and see exactly what was going on. So now when I click, it'll pull up this screen here, which is going to provide additional context. Right now we can see that the experience score specific to Workday was 34%. Page speed slow. So that's why it got flagged. We can also see that we're not on Wi-Fi. Ethernet connection. We do have a VPN in play. And if we're talking about just, trying to connect with that site, we're not seeing packet loss. We're not seeing a ton of latency. Same with the VPN. We're not seeing a bunch of loss or latency here, but if we click into that, we can also identify, okay, perfect. This customer uses AnyConnect. That's a supported VPN by ThousandEyes. So we should be able to see up to that VPN head end and through it what performance looks like. So again, we're building the story. We would have an alert that was already notifying us of where to, initially direct our attention. However, I'm kind of taking us from the ground up here. We had no alert, no real data to work off of. Okay, so we can close this out. We know we've got that VPN. We know that experience score wasn't great. Well, let's take a look and see, what did response time look like for this application? Any trends? Right off the bat, again, just looking at Hans, what was this that happened here? Something. We hit a wall, and now response time is higher than we'd expect, right? And just looking at previous performance, 38 milliseconds, I mean, that feels fast. You would notice a 577 millisecond response time, absolutely. So this is probably right about when Hans called in. Just take a look here and check latency as well. Okay, this is expected, right? We see latency sharply increase as well at the same moment in time. So now we'd have to figure out why. So we'd hop down to the network. We'll keep our metrics on latency. I'm just going to scroll down a bit. We'll take a look at a few things. This path, as you can see, it looks a little bit different than the previous. Again, this is the endpoint agent. We had been working with the cloud agents previously. So our pathing will look a little bit different. The most noticeable, I would say, is this purple. So that is going to be our VPN head end. So we can see that we are currently going through a VPN when trying to connect with, again, Workday. Let's expand this out a bit. 6 potential instances of Workday. So now just seeing that red there and seeing the 51% loss would be interesting, right? We need to better understand exactly what's going on here. We'll keep things on latency. Just want to double check. It didn't say there was loss. Is that accurate? It is. Okay. So we're seeing latency, and in my opinion, it looks like up to the VPN head end. Now to confirm that, right here, we are basically hiding a bunch of hops so that this doesn't become an eye chart, just to keep it clean and visually appealing, but you can zoom in here. So we would double click, and now we'd be able to see some additional information as we make our way to this VPN head end. More red. So we can hover here, double click into that, and we'll see, okay, we are seeing some packet loss as we make our way towards this head end. But we're also noticing a few red lines, right? So we are in. We should have covered this earlier. Where's Hans? Hans is in California. Okay, and you can see I'm just kind of, every time I click, I'm just expanding one of these larger nodes that's showing you, hey, there's multiple hops here. But so long as there's no issue, we, again, to clean things up, we'll show it in this way. But we're in California. We're on Sonic Telecom. Skip a few hops, still in California. In California here, but now, what's all this red? Click in here and we can see, okay, California to Ashburn, we'd expect to see a little bit of latency. Oop, get out of here. Ashburn, now to London. Okay, so that's interesting. Why would I connect with a VPN out of London if I'm in California when we know we've got San Jose real close? So in this case, this looks like it's actually just going to be that we connected with the wrong VPN head end, and that was ultimately causing our issue. You can do some creative stuff within the platform, right? We can set up alerts so that we better understand when some of these nuanced things occur. You wouldn't want to have alerts popping every time somebody accidentally selected the wrong VPN head end. However, in this case, it's pretty clear that we're experiencing poor performance because our data is going from California to Virginia to London before eventually making its way. In this case, we're hitting a London instance because our VPN says we're there. This one's interesting. I like these kind of examples just because it's not glaring, right? It would be tough to identify this. Think about if you didn't have a tool like ThousandEyes. How would you figure out that we're connected to the wrong VPN head end? It's a simple thing, right? The employee should have identified that. But in this case, it would be extremely difficult to help that customer better understand. Aside from just, let's start from scratch, shut your device down, and then we'll reconnect to everything and just see if magically the issue resolves itself. But this is the type of stuff that, think about your customers and the VIP employees that they have, right? Poor experience with, let's say it's UCaaS, it's Microsoft Teams. This person is just noisy, they're not happy. They view IT as a commodity. It should always work. That all falls onto the shoulders of your network team, right? Because they will absolutely be blamed first. And in this case, this would be a fun one for whoever fielded that ticket to be able to tell whoever this is, hey, you know what, it's actually just the VPN you connected with. But all right, let's keep moving here. So the final use case that we'll take a look at today is going to be SD-WAN. Now, tons of customers. I've been on many of these conversations recently. SD-WAN, if the conversation isn't being had in regard to what vendor are we selecting, it's at least on your customer's radar. People are moving this way. I mean, just look at the Meraki business, right? It's booming, and all SD-WAN. But some minor differences with the way that we're going to provide visibility here and just the general test strategy. Okay, so just to reframe things, what are we looking at? This is going to be SD-WAN tests that are occurring inter-branch, right, between two enterprise WAN locations for a customer. We're going to be conducting these tests from enterprise agents. We have not yet looked at this agent type. So your enterprise agent is going to be operationally almost identical to cloud. They can both conduct a full suite of ThousandEyes tests. The biggest difference with an enterprise agent is this will have to be, we'll call it hosted by your customer. So it's software based, there is no hardware, but we do need infrastructure to live on. So ultimately, your customer would have to deploy these across their network as a virtual machine. Standard Linux package would work, Docker container. Healthcare, there's multiple verticals. Healthcare is the most obvious though. Many times they won't have the ability to have this enterprise agent deployed because there's no infrastructure at a health clinic, one of their smaller facilities. They'll have desktops, they'll have maybe an edge device, but in that case, we can deploy our enterprise agent on a small compute device. So Intel NUC is a great option. Raspberry Pi is also a place we can deploy an enterprise agent. And then we have a presence on Cisco devices. So to name a few, ISRs, ASRs, we all know about the CAT 93 and 9400s and the DNA entitlement program, Nexus 9s. That list will continue to grow. I expect, we're already CAT 9 purchases being made currently, and enterprise agent comes pre-deployed on it. I would say in the future, we'll see more and more Cisco devices with that capability. But all right, back to the test itself. Talk again about the type of metrics we're collecting. And with SD-WAN, we actually have to conduct two separate tests to get the full story. So, if we think about any SD-WAN technology, that provider will provide some analytics in regard to performance. You'll be able to use that data to confirm or deny if you're experiencing an issue. The challenge for your customers is trying to get real answers back to the business. Okay, we know this link is down. Why? Whose fault is it? And ThousandEyes is able to actually provide you with visibility into what's called the underlay. So the actual transit hops that this SD-WAN traffic will be traversing, we can show you when there's loss, who's to blame. Because even though it's SD-WAN, I mean, we're still riding the same internet that we would have been if it was a straight up direct over the internet connection. But okay, with that overlay and underlay, what we see very commonly is we'll have, if we're monitoring an application across SD-WAN, we'll have some of these specialized application metrics at the top. So this is a page load test. Again, render the full page, show if anything's being delivered in an interesting way or not at all. Is the actual loading of elements on the page causing the issue? And here we can see, using our trends down here, relatively flat, and then what happens right here. So we'll actually click into it. And we can see that there is a large spike in page load time. Let's go back to normal. Steady state, we can see our DOM load time, page load time during the event, exponentially, we see an exponential increase in that page load time. But we still don't know why. We would look at the table, see, okay, who's performing poorly? Pretty glaring here, right? San Jose is showing a massive uptick in the total page load time compared to the others. How about before? It was on par. It's actually one of the highest performing. Okay. So now we would want to understand, why is page load time so much higher here? So I'm going to put a filter, San Jose. Now again, zoom in here a bit. That dark blue line, that's going to be San Jose's performance versus the light blue solid, the average. So we can see that it's pulled up significantly. Go back to our map here. Just then. But why? Take a look at our waterfall. And we'll talk about what this data set's going to provide. So we'll notice a few different things here. If I hover here, we can see by domain, where are we seeing this page load time? So it is going to be this net data. It is a demo, so it says SD-WAN demo. I can also look at by provider. Where's that live? Okay, this is in Google. So now we can see between Cloudflare and Google, that's where our total response time. Those are the two providers that are delivering this content. Go back to domain. But this is much higher than we'd expect to see. So we'll scroll down a bit, right? We've got this waterfall showing us some great data. Again, render the full page, and then we can see by element, how much time by phase did it take to fully render. If this were an image, like these links can be clicked. Let me see if I can find you an image. And it's as far as I'm looking. A lot of JavaScript, but if there were an image, you can click that link and it'll bring you to, it'll open up another tab and you'll be able to view that image. But let's go back to when things were good and take a look. As we can see here, not the largest amount of time anymore. But as we scroll down, looking at these different elements, this is what it should look like, right? We're not seeing any one segment of these phases being much larger, significantly larger than what we'd expect. We're always going to see that wait time be kind of the lion's share of the phases in total time. Nothing looks out of place. Scroll back up when that event begins. Scroll back down. Now we can notice there is some additional receive time, right? We're now seeing this giant gray tail on a lot of these elements. Scroll down a bit more and see if anything else looks out of place. So now we begin to look, okay, who's delivering the different components that are now showing us a larger amount of wait and receive time. And we saw that earlier, right? We know it's coming from net data. Let's click through a bit. Let's see, what else changes? Is there anything else glaring? Looks to be pretty consistent, aside from now, we've actually got elements that are failing completely. So our total time, and this is where things get a little funky sometimes. Page load time is now less because images are failing. And this persisted, again, perpetual test. It's going to be running every 5 minutes on the 5 minutes. This is a long event. But now let's take a look at something for comparison. All right, we'll go back to our table. Let's look at Chicago. They were doing pretty well at the same point in time. And we can see up top here, that filter pulled through. We're below the average, well below it, and consistently performant. Let's back at our waterfall. Now, during this same event, we're not seeing anything out of place, and we would expect that, right? Because we saw it up here as well. But we still don't know why. We know San Jose was having an issue. We know that there was some high page load time, some high response time, but we would have to drill down to additional layers. Looking at HTTP server, I'll drop this filter off. We can now see that during this event, availability was there. You saw a little dip at the end, right? What was that? Receive. This is probably when the timeouts reach their peak. However, back here, availability doesn't really look to be an issue at all. Response time. This is somewhat interesting, right? We just see a correlation between response time from San Jose when we also saw that increase in page load time. But we'd want to better understand, okay, is there loss? Is there latency? You know, is this a network issue or not? And now just for demonstrative purposes, let's all assume, let's imagine that we did receive a ticket. You know, we've received a ticket. San Jose is saying they're having trouble connecting with just about anything. So we then want to take a peek. Was there packet loss, latency, or jitter? We do see some, but it's inconsistent and it's low level. How about latency? And this is a bit more interesting. Now we can see that there was latency, and where are we seeing it? Okay, we're seeing it from San Jose, and in this case, also London. Okay, let's look at San Jose. Oh yeah, that's more obvious. How about London? They've just been having a bad time forever. We'll go back to San Jose. So we'd want to see the path. And again, this is the overlay, right? So this is showing us a tunnel view. We're not expecting to see many hops here. This is supplementary data to what the provider is already going to be revealing to the customer, right? No matter the flavor of SD-WAN, you will have some analytics across the overlay. But in this case, on the left, these are our enterprise agents at our customers' different branch locations. And what we're targeting, San Jose to San Francisco, London, Chicago here, and Ashburn. So these are like across the campus, you can think of it, right? So we're just looking at all of those critical connections that make up the wide area network that is now SD-WAN for a customer. So glaring red line. Wait a bit of link delay. We can hover here and see we're in San Francisco. San Francisco, we don't expect to see this kind of link delay, you know, especially between two hops. But we don't know the full story. We just have the overlay. With ThousandEyes, you could generate a similar test that's going to look at, instead of that tunnel view, it's going to show us hop by hop the networks that our data is traversing. And when we conduct a test like that, you'll notice that the packet loss looks far messier. How about latency? This is the same period of time. You know, there's our wall. So, you know, the consistency, the way that we get there when we would be triaging this type of issue, your customer they'd have dashboards up, right? So we would configure and push this data into a dashboard. We'd have alerts configured. They'd receive an alert. They would then hop into their dashboard view, just showing overall SD-WAN performance health. Overlay right next to underlay. They would see latency is what would have triggered this across both the overlay and underlay, because that's the most consistent. And ultimately, they would hop into this view, right? They would have seen that overlay. We've got latency, but now why? So if I click over a bit to where the event begins, we can now see from London, 28% loss and 343 milliseconds of latency. Let's take a look at the path visualization, because now we've built our story, right? We know what's going on, but we don't know who to blame. And all we know is that the network team is being asked for answers, and we, without ThousandEyes, have no real way to defend ourselves. Okay, so we've got some additional colors down here on the bottom, the path viz, that I would like to call out. So we looked at Cloud Agent Test. That was the visualization that's very similar to this. Biggest difference here is that now we've got these dark blue nodes. So if we're coming out of San Jose, branch location, connecting with, in this case, it's going to be another location across campus. These dark blue nodes are going to be nodes that are within your customer's network. We'll then egress to our transit hops, and then eventually we'll hit the teal, which is going to wind up in this case being the target network. So the big difference, right? The main thing that is going to be different from that overlay test versus this underlay are those transit hops, the light blue. But now when we see this latency occur, we notice some red here, right? We are seeing about 8% forwarding loss. But let's click through a bit and see if anything else lights up. Okay, now we can see that we have a node that's dropping significant packets in the Comcast network. And this is an interesting one, right? Because I was 100% expecting to see loss in these transit hops. I wasn't expecting to see in the underlay the loss occur so close to where the test would terminate. But it remains persistent. We can highlight that node. The latency here, that's always happening, the forwarding loss rather. But as I click through, see that, the amount of hops to get there, that may change round to round. We may not see that packet loss on a round. But the idea is we're alerting based off, this deviation from the average. Then when we get into the triage view, it becomes pretty clear that this issue is going to be on the Comcast side. And ultimately, we would have data, this data right here, to share with Comcast. If you notice at the top in my URL, share.ThousandEyes. So I haven't been in the platform once during any of these demonstrations. This is the data set, the read-only version of the platform that you can share out with a provider, with others internally, to try to find that root cause and just ultimately break down some of the silos, play off the same sheet of music. Where when I first joined ThousandEyes, where I thought there would be the largest impact was kind of bridging the gap between the network team and the application team. And that happens, but it's rare. And I really didn't anticipate that coming into this space. But especially, and I've seen it very prevalent within the Cisco customer bases, there's not a lot of communication that's being had between those two teams. I mean, AppD, they'll tell you that's their pain daily. However, this is a great way to kind of bridge that FSO story. Your network team cares about this. The application team, they do as well, they just don't know it yet. So when there's a large issue, and these don't happen often for your customers, once a year, twice a year, where it's all hands on deck, long war room calls, they're rare, they're infrequent, or at least you hope so. But this is the type of data that would allow that war room to only focus on who needs to be there, right? We don't need everybody, and then we cut heads as we kind of, discover things. It just makes the whole process much easier, much more streamlined. And ultimately, now your network team, they have answers. They can go back to the business and say, yes, this occurred. It was the network. Here's why. And we need to invest in X, Y, and Z so it doesn't happen again. And that's good for everybody, especially good for the Cisco generalists, right? Because hopefully it's hardware. But in regard to the demos, that's pretty much all I had prepared for today. If anyone has questions, by all means, we can field those now. And hopefully this was valuable information today. Do I get dinged for not filling the full hour?
No, but if there are any questions, yeah, feel free to come off mute. And, all right, I think we're all set then, Mike. Thank you so much for presenting. That was really valuable.
Fantastic. Thank you, everyone. Really appreciate the time today.
All right, guys, just a reminder, this will be posted on the Philly Select website. Other than that, have a great weekend, and thanks for joining.
everybody.
Hi all.